Another example. Here we are going from phasor form or a polar form into time domain expression. Okay, find the time domain expression for the phasors. You see there are two phasors here. One is right there and another is right there. And then we are supposed to find a subtraction between these two. Okay? So the best thing to do would be to convert each of these into their respective rectangular form. Okay, let's start there. So this one I'm going to write 20 cosine 45 degrees plus j 20 sine 45 degrees. The other one I'm going to write pretty much similarly, negative there, 50 cosine negative 30 degrees plus j 50 sine negative 30 degrees. Okay, straightforward. Now you plug this value into your calculator. This is going to come out to 14.14 plus j 14.14 as well. Okay. Similarly, negative 50 cosine negative 30 is going to be, what is it? Negative 30. 50 cosine negative 30, right? So 50 cosine negative 30 is going to be 43.3. Okay. Sine negative 30 is negative j. Negative 30 is sine of negative 30 is half. So this is going to be 25. Okay. So negative j 25. Now what you can do is to similar to what we have done in the past, we are going to handle the imaginary parts separately and the real parts separately, really easily. Okay, now that's the real part right there. So 14.14 minus 43.3. Okay, so that is going to come out to 29.16. Okay, so now the real part is going to come out to 23. Let me stick to one color here. 23 or negative. You see negative 29.16 plus j, okay, plus j 39.12. Okay, the reason is this negative multiplies with that negative, so j25 is going to add. So this is the rectangular form. Let me space this out a little bit more like so. This is the rectangular form, the time domain expression for the phasor. Now, if we are to calculate, okay, this is not the time domain expression yet. This is just the rectangular form, remember? Now we want to convert this rectangular form to polar form, okay? Once we have the polar form, we can take the inverse phasor transform, okay? Now let us convert this to polar form. Polar form is r angle theta, where r is given as square root of x squared plus y squared, where this guy is x and this guy is y. Okay, x squared plus y squared, you have 48.81. Okay, this is going to come out to, that's the magnitude. How do you calculate theta? Theta is tangent inverse imaginary part 39.12 over the real part negative 29.16. Okay, This is where we have to be extremely careful. If you plug this into your calculator will tell you that this is negative 53.32 degrees. Okay? This is not complete answer. This is misleading. The reason is this. If we go back and look at what we have done in the past, okay, we wanted to do a sanity check, right? Sanity check. Earlier, our answer was lying in the fourth quadrant, 10, negative 5, okay? 10, negative 5. Now, think about it. Our point is in what quadrant? The real part is negative. The imaginary part is positive. So what quadrant does that make? Real part is negative. Imaginary part is positive. So your point is somewhere in this, okay, quadrant, the second quadrant, okay. This is what you're looking at when you see negative 29.16 plus J 39.12. The real part is positive. The real part is negative, sorry, and the imaginary part is positive. So that happens in the second quadrant right here. The imaginary part is positive, real part is negative. So if you look at the calculator will tell you an answer of negative 53.12. So if you do it negative 53.12, it's going to turn out to be in this quadrant. Okay, this is negative 53.12 or 32, sorry. But this is not the answer. Our answer lies in this quadrant. So all we have to do is to add 180 degrees. Okay, if you add 180 degrees to the solution here, the reason is because the real part is positive, real part is negative, the imaginary part is positive. Our answer should be in the second quadrant. Okay, therefore, to negative 53.32, we simply add 180 degrees. Okay, that way the values all remain the same, but the polarity is appropriately captured. So this turns out to be some 126.68. Therefore, the final answer is, okay, the final answer is 48.81, right? 48.81 angle 126.68 degrees. So you can write it in V m cosine omega t plus 126.68 degrees, where Vm really is 48.81. Okay, this is the time domain expression of the voltage. Are we looking at voltage or current here? This is current, so we're going to write it as I in milliamperes. Okay, all of this is in milliamperes because the original problem was given to be in milliamperes. Okay, so this is the time domain expression. Sometimes the Moodle expects you to arrive at the phasor equivalent or the polar form, and you can leave it there. But if the Moodle is expecting a time domain expression, you can write it like so as well. But now you do understand the method behind madness of adding 180 degrees because you want to make sure that the position of your real part and imaginary part are accurate. Okay, think about this. The reason you're having to do this is because your calculator does not know the difference between tangent of negative 5 over 10 or tangent inverse and the tangent inverse 5 over negative 10. Okay, here the real part is positive and the imaginary part is negative, whereas here the real part is negative and the imaginary part is positive. Okay, so to a calculator, both of these appear like tangent inverse of negative 0.5. But to us, we know the subtle difference between having a numerator negative or having a denominator negative. So we have to pay careful attention. Okay? All right. I'll see you in the next example.